Hello all, I hope you can hear my voice. Nobody's in this room yet. But to make a good use of my office hour, I will do some problems from our book on 7.5. Let's see. The technique of integrations. I hope you already read that 7.5 and watch the lecture video. Then let's do some problem. For example, 7.5 number 2. Number 2, we have integral from 0 to 3 of 3x plus 1 to the power of square root of 2 dx. Our issue is actually here, right? So let's do substitution first on this. I will do substitution. U equals to 3x plus 1, so du equals to 3 dx. And therefore dx will be substituted by du over 3. Let me go to the right. So this will be equal to integral when I plug in 0, that's equals to 1. When I plug in 3, that equals to 10. So the left hand limit is of the integration is 1, right hand limit of integration is 10. 3x plus 1 now becomes u to the power of square root of 2 du over 3. And I hope you can see the substitution. This guy becomes this. Right? And this guy becomes u. Don't forget that the limit of integration should also change. Okay, okay, I will go on. The integral of u to the power of radical 2 will be 1 over radical 2 plus 1 u to the power of radical 2 plus 1 from 1 to 10. That will be 1 over radical 2 plus 1, and then 10 to the power of radical 2 plus 1 minus 1 to the radical 2 plus 1, which will be, if I rationalize this, multiply by the conjugate, I will get radical 2 minus 1. This guy is 10 to the power of square root of 2 plus 1 minus 1. I believe that's the simplest solution I can get. Second, this is the final solution. Okay, I will go on. Let's see, how about number 4? 4, integral of sine cube x over cosine x dx. Honestly, I don't know what to do here. Let's see. You know what? I think I have extra sign to work on. then I will change this sine x here becomes 1 minus cosine squared. So that would be 1 minus cosine squared x over cosine x sine x dx. And then I do the substitution, let u equals to cosine x such that du is negative sine x dx. So later on, I will substitute sine x dx here by negative du. So this is equal to integral 1 minus u squared over u times negative du. That's negative, negative integral 1 over u minus u du. Let me go to the let me go on. This is negative natural log of absolute of u plus 1/2 u squared plus constant. Oh no, I think what happened earlier. Yeah, I put the u back and scroll it up. Give myself some more space. This is negative natural log of cosine x plus 1/2 cosine square x plus constant. Of course, this guy here, I can go a bit further. This is natural log of 1 over cosine x, right? Imagine if I bring the exponent to the top here. If I bring the exponent, negative exponent to the top here, it becomes the power of negative 1, right? And therefore, eventually, it becomes secant. Now, I have to keep reminding you that technique of integration, the result that I have here may not be unique. For example, it is possible that somebody do it another way and get instead 1/2 cosine squared. Instead of 1/2 cosine squared x, that person get 1/2 sine squared x. Now, be aware that it is possible because, let me write it down here, because sine square x plus cosine square x equals to 1. Okay, so you can always replace cosine square x by 1 minus sine square x. Okay, so the cosine square x here may later on becomes sine square x, and whatever the constant left over, actually get together with the c. Okay, now let me see. It seems like there's another way to do this problem, even though I may not like it. Another way is you multiply the top and the bottom by cosine squared. Okay, and then at the bottom you will have cosine, I'm sorry, top and bottom by cosine x, and then at the bottom you will end up with cosine squared x, which then you will write as 1 minus sine squared x. Let me give you the glimpse of what I have in mind. Just an alternative view. So you can write this as sine cube x over cosine x times cosine x over cosine x. Right? And then this becomes, I fast forward, okay, sine cube x cosine x on the top stay the same. At the bottom you have sine squared x, cosine squared x, which I can rewrite as 1 minus sine squared x. Now then you do the substitution. You do the substitution sorry, F theta d dx. When you do the substitution, u equals to sine x, and du equals to cosine x dx. Then you end up with integral of u cubed over 1 minus u squared dx. And from there you go on. But in this case, you need to use partial fraction decomposition. Okay, let me go on. Let's do number 6. Integral from 0 to 1 of x over 2x plus 1 cubed dx. As you can see, our problem is here. Right? Let's call it u. Call it u equals to 2x plus 1. So u is 2 dx. Right? And therefore, u0 is 1, 1 is 3. And my integration now becomes integral from 1 to 3. Oops, what is my x now? My x now should be, let me take it from here. My x now becomes u minus 1 over 2, right? That's u minus 1 over 2. And on the denominator, I get u cubed. And I get u over 2. Because of dx is du over 2, right? This guy becomes this guy becomes this, and 2x plus 1 cubed becomes oh, I'm sorry, my x becomes u minus 1 divided by 2. Let me go on with the integration. So this is equal to 1/4 integral u minus 1 over cube from 1 to 3, which is integral from 3 of u to the power of negative 2 minus u to the power of negative 3. I think you can go on from there already. You don't need to do, right? So that's for number 6. Number 8. Integral of t sine t cosine t dt. Wow, this one is a bit harder. But I see these as two parts. This guy here with this guy here. It seems like I need to do integration by parts. I, from the top of my head, I can think of a couple ways to do this problem. But let me do the simplest one possible. I will rewrite this sine t cosine t. We know sine 2t is equal to 2 sine t cosine t. Right? So I can use that information to make it 1/2 t sine 2t dt. Then from there, I will apply integration by parts. Like you know, I tend to use the tabular method. This is 1 0. The integral sign is negative 1 half cosine 2t. This is negative 1 fourth sine t. So the answer here will be 1 half times negative 1 half t cosine 2t minus becomes plus 1 fourth sine 4t, and I put the constant at the end. Finally, the answer will be negative 1 fourth t cosine 2t plus 1/8 sine 4. On number 10, the graph from 0 to 4 of x minus 1 equal over x squared minus 4x minus 5 dx. Let's see. This is x minus 1. You know, we will do partial fraction composition. Right? So x minus 1 over x minus 5, x plus 1. Something over x minus 5 plus something over x plus 1. Right? Let's simplify by the LCD. I will have on the left hand side x minus 1. On the right hand side a times x plus 1 t times x minus 5. I think I will use the special value method. So when x equals to 5, I will get 5 minus 1 equals to a times 6 plus 0. So 4 equals to 6a, a equals to 2 thirds. While when x equals to negative 1, I'll get negative 1 minus 1 equals to 0 plus b times negative 6. Oh yeah, that's right. Okay, so negative 2 equals to negative 6b, therefore b is 1 third. Okay, now let me go on. From that partial fraction decomposition, then we get integral from 0 to 4 of x minus 1 over x squared minus 4x minus 5 dx. That's equals to integral from 0 to 4 of 2 thirds, that's my 8, right? And then dx over x minus 5 plus 1 third integral from 0 to 4 of dx over x plus 1. Okay, let me go on a little bit further, but I believe we can finish it from here. Integral that is natural log of absolute x minus 5 from 0 to 4 plus 1 third natural log of x plus 1 from 0 to 4. And from there you go and simplify yourself. Okay, let me stop the Let me start the recording.